That's a fallacy! When most people are introduced to logic, the first thing that they're introduced to are logical fallacies. But what is a logical fallacy? Fallacies are, roughly speaking, red flags in an argument. They're things that indicate that something might not be entirely right here. But what if I were to tell you that it's not a done deal? It doesn't mean that the argument is wrong. There are two types of fallacies. There are formal fallacies, which means that there is something structurally wrong with what was said. And then there are informal fallacies. Now, of the formal fallacies, there's actually not very many of them. There is one called Affirming the Consequent. If something is a square, then it is a rectangle. Now, if you try to do that backwards, this is a formal fallacy. This is affirming the consequent. This thing is a rectangle, therefore it must be a square. This is broken. This is wrong. That's not the way that logic works. You can't go that way. That's a huge problem. The other one is trying to deny in this direction. It's called denying the antecedent. So again, same statement. If I have a square, then it has to be a rectangle. I have a thing, and that thing is not a square, so it can't be a rectangle. That doesn't work either. You can have a rectangle that's not a square that is still a rectangle. And so those, we'll just leave those aside. Those are the formal fallacies. Over here we have the informal fallacies. One of the most famous of the informal fallacies is the false binary. Something is said like, you're either for me or against me, and it leaves out, it doesn't talk about a third category that is available, where you just don't care, or it's not an issue that divides quite that way. Like, there's 13 solutions here, why are we only considering 2? Now, sometimes there are only 2 options. It's a legitimate binary. Remember that the name of the fallacy is a false binary, but what most people equate with that is that all binaries are false. That's not true. Sometimes when someone gives a binary statement, it actually is true. For example, I either have something in my hand or I don't. These are examples of things where there is a legitimate binary. Another example of a classic fallacy is the slippery slope fallacy. The way slippery slope argument essentially goes is to say that if this happens, then this will happen. 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 Logically, that works. If this, then this, sure. And then if you separately say if this, then this, sure. And then if you separately say if this, then this, sure. And if you combine all those together, then it is a valid observation to say that if A, then all this step way further down the line. Now, the trouble with that statement is that it should raise red flags. Because in order for an argument to be not only valid but truthful, every single one of those premises, every one of those individual statements, if A then B, if B then C, if C then D, if D then E, all of those have to be separately true at the same time in order for you to get from A to E in one jump. Now, sometimes you could have a string of statements that all work, all of them are true. But it only takes one spot in that chain to break it down to make it so that it's not actually necessarily true anymore. So fallacies. You could consider fallacies to be an inductive form of red flag. If you see a fallacy, it might mean that the argument is flawed and broken and wrong. But it might not. If you're new to the channel, please consider subscribing below. And if you enjoyed the video and learned something about logic, please hit the like button. Thank you very much.